Right, continuing our logarithms, we're going to look at some log properties. This first property is our multiplication. We have log at any base, and we can do this for any base of log of u times v. This is going to be equal to log base a of u plus log base a of v. And it seems like kind of a strange thing, but let's look at why it works. Let's look at log base 2 of, say, something like 4 times 8. All right. Now they say that this is going to be equal to log base 2 of 4 plus log base 2 of 8. And let's say we don't quite believe it, so let's see what this actually equals. Let's look at the left side, see what it equals. We'll work down. Then we're going to look at the right side and see what that equals. Log base 2 of 4 times 8 is 32. Log asks the question, how many powers of my base do I have? And this answer is going to be 5. So let's look at this thing. Log base 2 of 4. What does that equal? That equals 2, because how many powers of my base do I have? Plus log base 2 of 8. That's going to be equal to 3. Oh, I see. When you multiply, you add exponents, and logarithms refer to exponents, and it is basically just adding the exponents. Okay, so I see why that works. These log properties are going to come in handy whenever we're solving equations, which is what we'll do in the next topic. We're going to look at the division property next, and let's see if it makes sense that there's a subtraction sign here. Well, when I divide, what do I do with exponents? I subtract them. Oh, I see. When something's in the denominator, it refers to a negative exponent. So you're going to find that anything that's in the denominator is going to have a minus sign in front of it, which refers to the exponent. So let's look at our example to kind of prove it to ourselves. And of course, this doesn't actually prove it, but it proves it kind of, we can get some logic out of it just by looking at it and showing how it works to ourselves. So let's look at log base 2 of, let's say, 32 over 2. Now our log property says that this should equal log base 2 of 32 minus log base 2 of 2. And what is 32 divided by 2? That would be 16. How many powers of 2 is 16? That would be 4. Let's see if this does indeed equal. Log base 2 of 32 is 5. Minus log base 2 of 2 is 1. Okay, so I am basically just subtracting these exponents, which is what a log refers to. And that's our second property. We'll be looking at the power property next. And these properties are going to come in handy whenever I have x's in here and I'm trying to figure out how to solve these equations. This is the power property, and I've got log of some base a raised to of u raised to some power. And what happens to exponents when I have a power raised to power? Well, you actually multiply, and you're going to see that you have this n times this log quantity of log base a of u. So let's look at log base a, but not a, I wanted 2. So let me erase that, put a 2 there. Okay, I fixed that. So we're going to say a 4 to the third. All right, our log property says that this should equal 3 of log base 2 of 4. All right, well, let's look at this little deal right here. 4 to the third is actually 64. And log base 2 of 64, I believe that would end up being 2 to the 6th power. So let's see if that works over here. This is 3 times, what is log base 2 of 4? That would be 2, because 4 is 2 powers of 2. And this does indeed equal 6. Okay, now I've got some example of why this property actually works. So let's use them to do a few problems. All right, the one I've chosen for you today, what we're going to do is we're going to expand this, and that's what the directions will say. It'll say use the properties of logarithms to expand the following. So it's kind of like an accordion. We're going to take this thing that's squished together, and we're going to expand it way out. Then they're going to give us one that's expanded and ask us to squish it together. So I actually have two things that are being multiplied, and it's going to be divided by this. So I'll do this in a couple of steps. I'll say log base 2 of x squared plus log base 2 of y cubed minus log base 2 of the square root of z. Now the square root of z could be written as z to the 1/2 power. So I'll actually use that to bring that power out front and get rid of these exponents sitting there on these variables. So I'll use my power rule to bring my 2 out front. 2 log base 2 of x plus 3 log base 2 of y. And I'm going to use the fact that this is to the 1/2 power. Bring that guy out front to the 1/2 log base 2 of z. Now I've expanded this bad boy. Alright, now we're going to take one that's expanded and squish it together. Alright, we're going to take something that's way expanded out and we're going to squish it all together. Now anything that has a plus sign in front of it actually goes in the numerator, and if it has a minus sign in front of it, all this stuff goes in the denominator. So what we're going to end up with is I'm going to take care of these powers first. I'm going to say log base 3 of x plus 1 quantity squared, and then I'm going to take care of this 1/2. I'm going to say that it's minus log base 3 of the square root of x, and then I'm going to have minus, and then we'll say log base 3, and this is going to be the square root of, because this 1/2 is being distributed all along through there, z cubed. Oops, and I wrote an x there. It's supposed to be a y. Let me fix him. There he is. Okay. Then we're going to have log base 3 of x plus 1 quantity squared. And then in the denominator we'll have our square root, and I'm just going to write it all as 1 square root of y z cubed. And there it is. Isn't that pretty? You'll actually use these properties whenever you're solving equations in the next video.